Okay, students, so today we're actually working on an extension lesson. We're in Chapter 4, Lesson 4.3 Extension. So this one's called Areas of Composite Figures. So the learning target today is I can find the area of composite figures. So we'll get that in our notes to start with. And in our green math book, we should be on page 172. So remember that this is an extension lesson, so it's going to be a little bit shorter, and your assignment will be a little bit shorter as well for this one. So the first thing we'll probably want to do is talk about these words, composite figures. So we need to know what those are in order to be able to find the area of them. So we'll title that in our notes. So composite figures. And at the top of page 172, we'll read what those are. So it says a composite figure is made up of triangles, squares, rectangles, and other two-dimensional figures. And then it shows two examples of composite figures. Underneath those, it says to find the area of a composite figure, separate it into figures with areas you know how to find. Then find the sum of the areas of those figures. So basically, a composite figure is kind of a combination shape of more than one shape combined, and you'll have to find the area of each piece and then add those pieces together. So we'll draw those couple examples that they give us. So they give us an example that kind of looks like a house here. So if I were to take this composite figure and separate it into two chunks, I could go like this. And now I have a triangle on the top and a rectangle on the bottom that I can find the area of. And then the second one looks something like this. And if I wanted to separate that up, I could do this, and we have a square on the top and a trapezoid on the bottom that we could find the area of. So over here, we'll just kind of put in words what a composite figure is. A figure that can be divided up into two or more simple polygons. Or two or more shapes, if we want to say it a little bit easier. So to find the area, again, we would find the area of each piece using our formulas we've learned so far in Chapter 4, and then add up the pieces. So we'll go ahead and get to our examples next. They're going to give us some different composite figures to find the area of here. So looking on that same page, finding the area of a composite figure. So this one, our purple figure here, is on a grid, and it's not actually giving us any of the measurements at first. So we're going to go ahead and try to draw this to scale if possible. So if you have squares inside your notes, this will be a little easier for you. The top side looks like it's 4 units long. So we're going to go ahead and draw 4 boxes, and we can label that 4. And then it goes down 1, 2, 3, 4, 5, 6 units. So this is going to be kind of big in my notes. 3, 4, 5, 6. On both sides, it goes down like that. Your boxes in your notes hopefully are a little bit smaller than mine are. I could use these teeny tiny ones, but those might be too small. Then it's going to slant on the sides, and it's going to slant across 2 boxes on both sides. Whoops, let's redo that line a little bit better. And then it just goes straight across on the bottom. So we know this top section is 4, and this side section here, we counted 6 boxes. We can count up the bottom here. We have 1, 2, 3, 4, 5, 6, 7, 8 right here. So we're just counting up the boxes to find some of the side lengths. Now, if we take a look at this composite figure, we can separate it into 2 chunks here if we drew a line this direction. This top one would be a rectangle, so I'm going to label it R for rectangle. This bottom would be a trapezoid, so I'm going to label it trap for trapezoid, so we know what the formulas would be that we're going to be using. So let's focus on our rectangle first. So when we're dealing with a rectangle, we're going to put R. Here's my rectangle. We're going to go length times width. So our length, it's kind of tipped over on its end, would be 6 times the width, which is 4, which gives us a total of 24 units squared for that section. Then the bottom piece is a trapezoid. So trying to remember our trapezoid formula, this was actually from our previous lesson. Remember, we take the height times base 1 plus base 2, divide all of that by 2. So looking at our trapezoid, we don't have all the numbers we need yet. So remember, this top piece would probably be the same length as this piece here. So this is going to give me a 4. I already know my other base, but I need to know my height. Remember, the height is from the top of the trapezoid to the bottom. That looks like 2 boxes. So if I do this math, it would be 2 on the outside of the parentheses, 4 plus 8 for my bases, and then I would divide by 2. So 4 plus 8 is 12, and then we can multiply that by 2, which gives me 24. And so I've got 24 cut in half, which gives me 12 units squared. I'm very close to being done, but I have to add these two together to get my total composite area. So I have 24 plus 12, which gives me a final answer here of 36 units squared. Make sure you label that final answer. And we've got it. So then we can move on to page 173. And there's example 2 sitting there, and this one's a real life situation. So let me switch colors here, and then we'll read that one together. Okay, at the top of page 173, it says find the area of the fairway between 2 streams on a golf course. It gives us a little picture there of some different measurements and a fairway on a golf course. So it says there are several ways to separate the fairway into figures whose areas you can find using formulas. So we're going to have to figure out how we want to separate this figure up. So let's first of all draw the figure. If you look at the 2 blue sections on the picture, those are going to be our rivers, or our streams they're discussing here in the question. We're trying to find the area between the two. So the shape that we have in the golf course kind of starts here and goes straight down and straight over. Then it goes up, but not all the way up, about to right there. Then it cuts over. Whoops. Cuts over here. And then this kind of comes over. Oops. Keep doing that. And then, let's see, it goes to about there, and then it cuts down like so. So we've got this kind of shape that we're trying to figure out the distance of. It says this is 40 yards. This is 40 yards. It says this over here is 70 yards. They call this 40. They also call this line 40, even though I didn't draw it very well. This slanted side is 50. So they label all the sides for us. So if I were trying to find the area of this composite figure, I might want to chop this into a triangle chunk right here. And then this would be my rectangle piece. So that might be the way that I would want to solve it. So if I do it this way, I've got a rectangle and a triangle. I'm going to start with my rectangle here. Rectangle, remember, is length times width. So I'm going to go 70 times 40. 70 times 40 gives me 2,800 yards squared. Now let's deal with my triangle piece. Remember, when you're finding the area of a triangle, it would be base times height divided by 2. So the base of my triangle here would be 40 yards. Now the height of my triangle is not going to be 50. It's going to be this distance right here. So we don't actually have that labeled right now, but we can figure it out. If this entire side is 70, and then this chunk of it is 40, we can take 70 and subtract 40 to get this height. 70 subtract 40 would give us a 30. So this little piece here would be 30 yards. So I'm going to take 40, times it by 30, and cut it in half to find the triangle piece. So that would give me 30 times 40 divided by 2. So 3 times 4 is 12 with 2 zeros divided by 2. So that gives me 600 yards squared. So then lastly, we need to add our two pieces together. So we have 2,800 plus 600. I'm going to put my answer at the bottom here. That gives me a grand total of 3,400 yards squared for my total area between the two rivers that it shows on the picture. And there we have it for example 2. So there are no try it on your owns on this lesson since it's an extension. So that brings us to the end of the lesson.